My speakers all second.
Henry. But first of all, I have to talk about some story between us. I just know you for very few months.
Actually, a long time on Facebook.
A long time on Facebook. Actually, we're a stranger, but we become close friends after he comes to Singapore more often. Okay, Henry, we'll do a short intro to the church H here. So Mark is from Hong Kong, yeah? Yeah, because he travel around, so sometimes I'm a bit confused whether he's from Singapore, Hong Kong, or whichever country. Okay, Henry.
Okay.
Let's welcome.
All right, let's welcome Richard Mark. Ladies and gentlemen, Richard will be talking about the turntable setup today. Am I correct, Richard?
Yes.
Okay.
You're absolutely right.
Absolutely right. I have no idea what he's talking about. Okay, give you an idea about Richard. Richard is actually the inventor and the CEO of Analog Magic, the world's only all-in-one turntable cartridge calibration software, which has been covered by audio magazines in over 20 countries, and he has won awards in Japan and in Europe. So this is the man you want to talk to find out more, exchange ideas with him. Hopefully he will tell you some of his secrets here and there. So be nice to him. So ladies and gentlemen, I give you Richard Mark. Let's give him a big round of applause. Richard, do you need the microphone? Sure.
I think I do. Do you need to stand or something?
No, I think this should be fine.
Okay, thank you.
So I'm Richard Mack. Thank you for coming to my seminar. I actually don't do these very often, but it just so happens that I'm in Singapore and I am now a resident of Singapore. So how can I not contribute to this country? Turntable setups. My turntable journey, setup journey, actually began in about 2005 when I wanted to, perfect my setup skills. And at the time, I really didn't know what the hell I was doing, so I was, scouting the internet and asking a lot of, friends or grandmaster or Sifu's help, if you know what I mean. And so I began going around town, setting up a lot of turntables, beginning in 2005, experimenting, using a lot of my friends as my guinea pigs when I first started out. And I think between 2005 and 2010, I've set up over 2,000 turntables. And luckily, I've been in the homes of over 500, I lost count, but my estimate is about 800 audio files from around the world. Anywhere from Germany, Japan, Portugal. And I've learned that different countries have different cultures, but that actually translates into turntable setup as well. Some countries, they have been using certain methods for many, many years, and some are very scientific, some is almost like a religion. And so turntable setup can sometimes be a black box if you don't know what you're doing. And in Singapore, I noticed that usually your favorite dealer, when you buy a turntable, they will set it up for you. There's not a lot of home users for turntable setup in Singapore. And there's no reason for that, because a lot of people invest $5,000 or sometimes even $50,000 on a cable. And they have $200,000 turntable, $10,000 cartridges. But when I ask them, what tools do you use to set up your turntable, and they'll tell me, I don't know how to do it. And it just doesn't make sense to me, because it is like someone buying a Ferrari and then he tells you that my driver is the only one who can drive it. I don't know how to drive it. Now the difference between a good setup and a bad setup can be dramatic. And if we're investing that much money into the equipment, why not spend a little bit of time and energy and figure out how to set up a turntable? I think we need to shift this down a little bit. There we go. Now, before you set up a turntable, you need to ask yourself, what is the goal of setting up the turntable? what are you trying to achieve? Because this question will always come back to this question on everything that you do on setting up turntable. What is each procedure trying to achieve? And if you don't know the goal of, you don't know the goal or the benchmark or what you're trying to do, then it becomes a black box. For some people, the goal of setting up a turntable is to impress some guru friend or grandmaster or reviewer that they come to their home, and the grandmaster will sit down and say, I think this sounds good, and that becomes the standard. Well, there are two problems with that. Number one, that grandmaster, his hearing on high frequency will depreciate, or it will reduce in sensitivity by about 1 kilohertz for every 3 or 4 years. So that grandmaster, when he was 17 years old, his hearing ability is completely different than when he's 70 years old. So that becomes a moving benchmark. And when I'm actually designing a product to set up turntable, I have to ask myself, what am I trying to achieve, and what is that benchmark? To me, the absolute benchmark of setting up a turntable is to retrieve whatever that was recorded on the LP as accurately as possible at the lowest level of distortion. That is my benchmark. And every step, every procedure that I'm going to show you today will go back to this very question. Now, if that benchmark, now I like to stress that, well, what if I don't like the sound of a turntable setup that gives me the lowest level of distortion? You have every right to dislike the sound of something with the lowest level of distortion. However, if someone is paying me to set up a turntable for you, I cannot set up a turntable based on a third party or a third person's ear. My benchmark has always been retrieving signals accurately from the LP. What do I mean by that? Well, simplest answer, if I have a test LP with a 1 kilohertz signal, after I set up the turntable, that setup should be able to play back 1 kilohertz, not 0.9, not 1.9, not 1.1, not 1.5. It should be played back at 1 kilohertz with the lowest level of distortion. The second question I'd like to ask, what is the single most important thing in analog setup? Anyone know? The most important word in analog setup is correlation. You have, it is the ability to make an adjustment and to be able to detect a change either by your ear or by the distortion analyzer, and the ability to detect that change. Now you ask yourself, if you set up a turntable and you change one parameter, let's say if you change the weight of the cartridge, which they call VTF, and after changing it from 1.9 grams to 1.7 grams, if you cannot hear that change, or if a distortion analyzer cannot detect the change, then you have to ask yourself, what's the use of setup if you cannot detect the change? We're not doing it for visual satisfaction or psychological satisfaction. You have to be able to somehow measure the change or detect the change with your ear. So you bought a turntable from a dealer and you bring it home. If the dealer didn't install it for you, or you bought a new cartridge and you have the cartridge in your hand, where do you begin by setting up a turntable? Well, very easy. First step, mount the thing onto the head shell. Several things I like to say. Okay, us Asians have the advantage of having relatively small hands. Okay, I'm not sure about the guys from Germany. You guys tend to have bigger hands, and if you have big fat fingers, no offense, go get someone with small fingers to do it for you. Because I have seen people pull off, break off the cartridge clips or break the cantilever. Get someone with a nice fine fingers. I want to say another thing about the mounting screws on there. Now, how tight should that thing be? There's a lot of different ways, a lot of myth on the internet on how tight that screw should be. Well, my experience tells me the optimal torque on that screw is, let's say if this is the point of contact where you starting to feel that it's tight, just about 1/8 of a turn. And we have actually tested this using sophisticated tools on measuring the resonance of a cartridge body. So I do not say this arbitrarily. And it has a huge effect on the sound, on how tight you tighten up that screw. The best way to do it is to use a torque wrench. What happened there? There we go. You can buy one of these torque wrench from myself. I used to sell one. I don't really make money on it. It's more of a service because these things are very expensive. They're like $200 or something. But compared to your $15,000 cable, it's a drop in the bucket. And if you want to buy your own torque wrench, you tighten up that screw, the optimal torque is about 0.6-0.65 inch-pounds. It is the most accurate of doing it. And there are some companies selling torque wrench at about 6 times the torque tightness. And we've actually tested it on cartridges with such as 6 or some Lyra cartridges. And some of the tools they sell in the market actually crack the body of a cartridge because it was way too tight. So if you want to buy one that gives you 0.6-0.65 inch-pounds. Second thing you need, it's very important, but the problem is there is no universal standard on the screws. You can use standard screws. You can use our screws. I tend to prefer screws that are not magnetic. Because if you use a steel screw, it actually will interfere with the coil. It changes the sound a little bit. So use something that's non-magnetic. Aluminum screws are not bad because aluminum doesn't resonate at the frequency. It doesn't have weight, and so I like aluminum screws. So after you mount the cartridge on, the first thing you need to do before anything else is to make sure that the cartridge on the tone arm actually falls within the range of the weight that was recommended by the cartridge manufacturer. Because I've seen people, they put on a cartridge, they did alignment, did all the fine tuning, but they forgot to set the weight of the cartridge, and they were tuning the thing at 8 grams or something. By the end of the tuning, your cartridge is damaged. These things are a little bit silly because I have tested over 100 of these. They're all a little bit different. They're not very accurate, and they also, each one of them has a different height. So it actually, if you change the height, it actually affects the weight a little bit. Yeah. But you don't have to go crazy on accuracy on this because every cartridge is made by hand. So if the manufacturer usually gives you a range from, let's say, 2 grams to 2.1, and you saw some guy on the internet telling you that, well, 2.1 sounds the best, I'm sure it sounds the best, but for his cartridge. The same model of cartridge, from yours to his, may have a 0.2, 0.3 gram difference. And all these scales, even the most expensive one may not be the most accurate. So just get within the ballpark. And if you want to actually fine tune it using a distortion analyzer, Analog Magic is the only tool that can set the VTF for you using a scientific method. But we'll get into that. General lack of consistency with any of these. Cartridge specs are not exact, like I said earlier. So you can buy a $20 one or a $500 one. It doesn't really make much difference. So my advice is to go cheap. So you mounted your cartridge on the tone arm, and now you ask yourself, what am I trying to achieve? Well, you have to align the cartridge so that it sits at a spot where it retrieves the signals most accurately from the LP. How are we going to do that? Well, I've attended a lot of seminars where people will show you this diagram, okay, and they will spend an hour explaining to you what's pivotal spindle, what's this, what's that, and the theories behind it, and the scientific formula on how it affects distortion. I can safely say that as an end user, all this is bullshit. It's bullshit in the sense that you don't really need to understand the theory behind it, because they have been debating this for 50 years and they still hasn't settled on which geometry is the best. There are several out there, but as an end user, why do we need to get into that scientific argument? Right? I'm just interested in showing you how to mount it on, using the most common geometry, so you don't have to listen to me waxing eloquent and pretending to be expert to explain the science behind this. It is absolute bullshit. All you need to do as an end user is put the cartridge on the tone arm, and then usually on any turntable there's an arm board that's movable. If it is movable, it makes the setup job a lot easier. And every cartridge or every tone arm will give you a pivot to spindle distance. All you do is to have a tool that measures this to the pivot of the tone arm. And once you've got that, tighten up the arm board, and you're good to go on the next step. Usually for a 9-inch arm, that's usually around 230 to 235 millimeters. For a 12-inch arm, it's usually 295 to 305. Why is there a discrepancy here? Well, because there's no universal standard. Some cartridges have a long cantilever, some cartridges have cantilevers hidden way under the body. The difference is usually can be as wide a range as 1 centimeter. So that's why manufacturer will give you a range so that you can move the cartridge forward and backward. Now, setting up the pivot to spindle is much easier if you buy a tool such as a smart tractor. I think this is the best one on the market, and I'll tell you why. You basically put this thing on the turntable, and there's an arm that lets you adjust the exact measurements. You basically shift this to the pivot of the tone arm, and you set the distance properly, and you're good to go. Like I said, the best tool for the job, I think, is a smart tractor. I believe Bobby will be selling this soon, so if you want to get one in Singapore, talk to Bobby. Now, the smart tractor that you see here is built in with a vernier scale. Just by virtue of physics and measurements, the vernier scale is accurate to within 1/100th of a millimeter. So this tool can establish the pivot to spindles to absolute accuracy. This is what it looks like. You can set the pivot to spindle distance here, point it at the tone arm, and you're good to go. Once you've set the pivot to spindle distance, the second thing you do is to align the cartridge to the grid lines printed on whatever template you're using. Now, if you use a smart tractor, it has grid lines printed on the tractor itself, which makes the job a lot easier. And note that you are actually aligning the cantilever and not the body of the cartridge. Why do we not align the body of the cartridge? Well, because all the cantilevers are never perfectly straight. And if you align the body of the cartridge, there's no guarantee that your little needle or the stylus will land on the perfect spot. A lot of people print out these paper templates from the internet. This is actually a Fiker protractor, which is a good starting point. But in my opinion, the Smart Tractor is a lot better. Even just the grid lines itself is so much more smaller and more accurate. And also when you print these templates off the printer, your scale is messed up. Sometimes some printer gives you the wrong measurement, so it's not really a good way of doing it. Spend the money on a good tractor and get it done properly. If you notice a Smart Tractor, the point there you're actually trying to land on the template, on the Smart Tractor, it is a laser cut divot indented onto the template. That divot is smaller than the tip of the stylus. Whereas on most tractors such as the Fiker or a paper printed one, there's no indentation, and also the dot is fairly big. So you're not actually very accurate when you use one of these, off the mill templates. So I highly recommend the Smart Tractor. Now, when you're aligning the cartridge to these grid lines, the Smart Tractor has 2 layers of, it's actually a mirror template with grid lines on the top layer and the grid lines on the bottom layer. And if you use a paper template, the grid line is only one level. And what is the problem of using a alignment tractor with flat grid lines? Does anybody know? I'm not sure if this is a proper term, but if you talk to any surveyor, the guys with a tripod trying to measure, the boundary lines, a mile away, they will tell you that on any alignment, the viewing angle establishes the accuracy. Now, if you have a 1-layer grid line, and if you're viewing it with your head tilted 1 degree to the right or 1 degree to the left, if your viewing angle is wrong, your alignment will be wrong. So the only way for a tractor to give you a proper alignment is when there's 2 layers of grid lines. So before you even align the needle on the grid lines, you first establish your viewing angle. This is what I'm referring to. And this is what it actually looks like, blown up 300 times. These are on the top layer, these lines are on the bottom layer. So before you even have the stylus hit that dot, you first establish your viewing angle. And this is how you align a turntable cartridge using a tractor. You establish your viewing angle by make sure that the 2 lines completely overlap each other. Then you align the cantilever or the needle so that it's parallel to the grid lines. And the reason for doing that is because this will give you the proper geometry to achieve a lower level of distortion. And remember what I said about the divot, the dot where the stylus sits on? Well, on the Smart Tractor, that thing is a tiny little, almost the same size as a human hair. So there is very little room for error on the Smart Tractor. Now, 99% of the population will basically adopt this method. So they buy the tractor, they mount the cartridge on, they set the pivot to the spindle, and then they align the cantilever to the grid lines, make sure the stylus sits on the null point, they drop the lifter, and the needle lands on the dot, and they'll go, it's done, it's straight. Well, after aligning over 2,000 cartridges, I can tell you, the job is not nearly done. The problem with a static alignment, where you simply drop the cantilever onto the template, is because sometimes there can be uneven pressure based on how the cartridge is positioned. There can actually be 3 positions that will give you the exact same static alignment results. But when you try to lift the cartridge up, you will see that the cantilever can actually be going up on an angle. Does anybody understand what I'm saying? This is a little bit, this is from experience. If you basically just drop the cartridge and the needle drops on the point, you're assuming that it is landing straight. It is not. It could be coming up on an angle, which means that there will be uneven pressure on the cantilever. And over time, what will happen? It will bend your cantilever off to the side. I went around, watching dealers set up turntables, and I can tell you, almost 99% of them do not do this. The proper way to do it is a dynamic alignment, where you use your hand to cue the cartridge up and down, and you watch the landing behavior of the needle so that it is actually going straight up and straight down with the grid lines. This is probably one of the single most important tips in a cartridge alignment that I can give you. So remember it well. After you have aligned the cartridge, then you have to go through every step of setting up a turntable. And my product, you don't actually need my product, but it will be a lot easier if you use my software distortion analyzer and my test LP. Each of these things, you have to set up the speed, the bow and flutter, azimuth. You have to go through the whole enchilada to get an accurate setup. And there's no tool on the market that will allow you to do everything listed here other than my tool. It is the only one on the market that can set everything using the distortion analyzer. After you mount the cartridge on, you should always set the turntable speed, make sure that it is correct, because if the speed is wrong, then it affects the frequency. 1 kilohertz could be played back at 0.9, or it could be played back at 1.1, it will be a higher pitch or a lower pitch if the speed is off. And also, speed actually affects all other parameters. It is not independent, so speed is one of the most important components. A lazy man way of doing it is buying one of these stroke discs. I use this myself because it's quick and easy. You basically put the stroke disc on, play it, and shine a little red light on the template. And this little 33 or 45 RPM will wiggle a little bit, so you set the speed until the number is as stable as possible. But there's a problem with using one of these stroke discs. Does anybody know what the problem is? These things are usually, because once you put the stroke disc on the platter, you cannot really put the needle and plate at the same time. But when the stylus is sitting on the record, there's a dragging force that will actually slow down the platter very slightly. So what you've assumed to be accurate will actually slow down a little bit. So the most accurate way of doing it is using a distortion analyzer with a test LP with the needle playing on the album, and you basically check the speed. And on my product, you can do that because it will display the speed right on the screen, and you basically adjust it quick and dirty and easy and accurate. The next step is to adjust the horizontal level of the cartridge relative to the platter's lateral. Does anybody know what the goal of setting up azimuth actually represents, or what you're trying to achieve? A lot of people will tell you that, well, this is supposed to be flat and perpendicular, or level with the turntable platter. Is that what we're trying to do? Well,
Needle should be in the middle of the groove. The needle should be in the middle of the groove.
that's right.
Right angle.
That's right. It has nothing to do with visual satisfaction. You may feel good doing this at a perfectly level, but what you're going back to the goal of analog setup is your goal of setting up a turntable trying to achieve visual satisfaction, or are you trying to retrieve signals accurately? They sell these blocks. They're about $100. I've seen them as expensive as $300, or they can be $20 on eBay. In my opinion, they're not very useful because you can usually get one of these zero dust or any plastic box or a deck of cards and just wiggle it so that the head shell is perpendicular to the surface, of a deck of cards or something, and it'll give you a perfect lateral balance. You don't need to buy any plastic blocks to do that. And this does not depend on visual satisfaction because you can actually feel it, and there's no way that it will not be, not level with the platter. But is that what we're trying to achieve though? What happens to azimuth? And what is the effect of azimuth on the sound? Does anybody know? What happens if the cantilever is not sitting right or not flat to the surface?
Certain frequencies will be different.
Well, a lot of people think that, channel balance will be off. It is actually the wrong answer. Azimuth does not affect channel balance. In order for azimuth to affect channel balance, to have one channel louder than the other, you really have to tilt the thing to like 20 degrees or something in order to hear a channel balance. Azimuth has nothing to do with channel balance. If channel balance is incorrect, your playback of a viola on the right side, if your channel balance is off, if one channel is louder than the other, well then the viola will appear to be shifted from the right to the left if the sound is louder on that channel. But azimuth doesn't do that. Azimuth has to do with crosstalk. If your azimuth is off, the signals recorded on the left channel will leak slightly over to the right channel and vice versa. And think about what would happen if your viola, which is supposed to be on the right, and some signal is leaking to the left slightly, well, it will blur up your image. And when azimuth, it's not set up properly, the effect is it will soften up the sound and it will make it, make the image fatter, bigger, and more blurry. If your ear is good enough, you can probably set up using your ear, but I don't think it's the most accurate way of doing it. But that's the effect that it will create. It is not a channel imbalance. It will fatten up the image. What you're trying to achieve with azimuth is actually having the cantilever of your cartridge sit perfectly in the spot, so that it sits perfectly in the groove, in the record groove. If the azimuth is off, you may tilt the cartridge to the left or to the right, and this will show up on a distortion analyzer through a crosstalk analysis as an imbalance in crosstalk. So the goal of achieving perfect azimuth is so that there is an equal amount of signals being balanced or to minimize the leakage from left to the right, and to make sure that the leakage is equal on both channels so that it will give you the most accurate signal retrieval. And not all cartridges, the stylus, are mounted perfectly perpendicular to your needle. So do not be surprised if after setting azimuth that your cartridge can be tilted slightly to the left or to the right. My experience, it should not be tilted more than 1 degree because that usually fixes the problem. And if you end up with a setup with the cartridge tilting like 10 degree or 20 degree, like that, that's usually a wrong setup and it will probably damage your cartridge over the long term. On Analog Magic on my product, if you play the azimuth test track, my product will actually give you left-right channel crosstalk on the fly during playback. This makes setup very easy because you can actually change the azimuth with the LP playing with the stylus on the record groove. And all you need to do is to adjust the azimuth if your tone arm has that function so that these two numbers are as close together as possible, and that will give you the perfect azimuth. My product can actually do the vertical tracking angle at the same time, but we'll get into that. A couple of things I like to say about the azimuth. A high quality cartridge usually has a very high reading on this number. And on the specification brochure, this is actually called channel separation. Usually that number is better when it's higher. So if you have a cartridge that can achieve a channel separation of, let's say, 30 decibels or higher, it's a lot better than one which is, say, at 20. And you can actually hear the sound with a cartridge with high channel separation. Usually the image is a lot sharper and with a lot more detail, whereas a cartridge with a low channel separation has a much lower level of detail and air and whatever you call it. And like I said, if your azimuth is set, it's adjusted incorrect, it really affects the sound by it will give off sort of a mushy presentation, a fat, blurry type of stereo image. Next thing I want to get into is the vertical tracking angle, or the stylus raking angle. How many of you set tone arms VTA using, just eyeballing the level is of the tone arm? Okay. Which is fine. What are we referring to when we talk about VTA or the level of the tone arm? Okay. Well, you can call it VTA, which is this angle, or you can call it SRA, which is the stylus raking angle of the stylus relative to the surface of the LP. And the reason for setting VTA, there's a reason for doing this. Sonically, if the VTA is too high, it usually will reduce the bass frequency. It will tilt the sound up to give you a more shrill and more high frequency sound. And if you lower the VTA too much, it will sound very fat and woolly. But why does that happen? A lot of people on the internet and a lot of reviewers talks about buying a microscope and setting the vertical tracking angle so that this is exactly at 92 degrees. And you can go on the forums on the internet, there will be hundreds and hundreds of pages talking about the stylus raking angle. So in effect, when we're trying to set the VTA of the tone arm, which is the horizontal balance, we're trying to change the angle at which the stylus is reaching the LP at. That's what setting, VTA or SRA means. Some people advocate that this has to be exactly 92 degree, and they buy all sorts of expensive and silly microscopes to try to get this angle right. Okay? I have no problems with those who advocate this method, but I have 3 things I want to say. Number 1, how do you establish the viewing angle of using a microscope? So if you tilt your head by slightly, even half a degree, this angle will no longer be 92 degrees, it will be 92.9 or 92.1, depending on where your head is. And any surveyor will tell you that over a long distance, a slight tilt of the head to the left or right, your angle is off dramatically. Number 2, this is actually pretty silly because you can only do this on a static measurement. That means as soon as your LP starts spinning and music starts playing, whatever that you have assumed to be optimal, well, the dragging force will actually cause the cantilever to sag. And also, this is not an absolute static, even on the LP, because the LP, a lot of them are warped. And, so this thing is actually riding back and forth. You're not actually getting 92 degrees. So those who are advocating getting an absolute 92 degree have not think this through, in detail. And also, they're drawing, silly lines on their computer screen, thinking that whatever you draw on screen is accurate, and they actually use software to measure this angle. I think this is actually very silly because do you draw a line here, or here, or here? Like, which line are you supposed to use? I mean, this is completely arbitrary. So, in my opinion, quite useless to be buying these silly microscopes. And why is this supposed to be 92 degrees in the first place? Well, if you ask those who advocate this method, they will tell you that 92 degree will produce the lowest intermodulation distortion. I don't want to explain this in detail, but they will just tell you that it's gospel. 92 degree gives you the lowest intermodulation distortion. That's why they're going after 92 degree. Well, this is absolutely untrue because I have measured the intermodulation distortion on 92 degree, and I can tell you every single cartridge measures differently. It can be 91, it can be 98, it can be 89. 92 degree does not give you the absolute lowest intermodulation distortion. And my product is the only one on the market that I can actually perform a measurement. Well, it's not the only one, but you can actually buy a hardware distortion analyzer such as the Nutric A1, which I used to own before I developed my software. But in terms of a cartridge setup tool, I'm the only one on the market who has this functionality. What is intermodulation distortion? Well, let's say there's 2 test signals on the LP, and all these ripples are actually things that are not recorded. And these are actually distortion generated when your stylus is not at a perfect spot on the groove. And they call this intermodulation distortion. In a layman's term, the scientific explanation is actually a lot more complicated, but that's all you need to know. Well, if we're trying to achieve the lowest intermodulation distortion on analog setup, why not measure it with the LP playing? And on my product, you can actually measure azimuth and VTA at the same time on the fly. And what you do is basically change the VTA adjustment on the fly, and it will display the number on screen. You basically adjust it so that this number is the lowest. And that will give you the perfect ETA if you believe in setting up, vertical tracking angle based on the theory of getting the lowest distortion level. Now, I cannot guarantee that the lowest level of distortion will be what you like I said before. But if you're trying to achieve accuracy, my tool will do it for you. Last thing I wanted to talk about is anti-skating. Anti-skating is basically, does anybody know what anti-skating is? Because of groove modulation and also the different pressures generated with an LP playing on the groove and the offset angle, there is actually a force that pushes the cartridge towards the cantilever. And anti-skating is the force that actually counteracts this by applying a force that goes this way. There's a lot of weird ways of setting anti-skating on the market. I mean, it's somewhat pretty bizarre. I don't know if these are any of the methods that you use. Some people buy a grooveless record or a mirror, and they will let the stylus skid across a grooveless record and try to hold it at the spot where it doesn't move at all. Okay? This method is absolutely dangerous. Number one, a grooveless record has a different friction coefficient versus a real LP with grooves on it. So if you set the anti-skating using a grooveless record, you're setting it the wrong force because the friction coefficient is actually different. Some people will play this LP because this particular LP has the record grooves cut very close to the record spindle. And they'll say that you can play through that LP with a record groove as close to the spindle as possible without distortion. That's the correct anti-skating. Again, why are you setting anti-skating with an LP that is actually pressed, pretty badly or irregular? I don't think any of these methods work. And some people advocate buying this thing that measures bearing friction. And you're supposed to set anti-skating with an arm swinging in midair with this tool. And it goes back to, you have to ask yourself, what are you trying to achieve with setting anti-skating? Well, you're trying to achieve visual satisfaction, you can go ahead and buy this tool. Okay? But all these methods has nothing to do with anti-skating whatsoever. In my opinion, the most correct way of setting anti-skating is to understand why and what it does. If there's a balance of anti-skating, if it's set correctly, the stylus will be playing on the record groove, with an equal pressure to the right side and on the left side. If there's too little anti-skating, that means there will be a force pulling the stylus to the left side of the groove wall, and if it's too much, it will pull to the right side of the groove wall, creating an uneven pressure between left and right channel. Well, there's an easy way to set anti-skating, is to measure the distortion level between the left groove versus the right groove. All you need to do is to put this on the distortion analyzer and adjust anti-skating so that the left and right gives you perfect balance. And of course, Analog Magic does that for you. We will play through the record, and we have an algorithm that will actually generate the distortion level on screen. All you need to do is adjust it so that these two numbers balance, and you have the perfect anti-skating. Two things I want to say: if you have a 12-inch tone arm, usually requires almost no anti-skating. So if you don't know how to set it up and you have a 12-inch arm, forget about it, because you don't actually need it. And if you don't know how to set it up, you don't have the tool. Too little is better than too much, because having too much anti-skating force will actually bend the cantilever over time. So leave it alone if you don't know what you're doing. I think our time is almost up. I was going to talk about how to set optimal gain, how to set loading on your cartridge, but I think that's a little bit beyond the basic level. And I'd like to leave a little bit of time for a question and answer for anyone who wishes to ask any questions at all.